Awesome. And we're live again. I want to have some fun with these effects once more. Welcome everyone and GM, uh, GN or GE. We're glad to have you here. Thank you for tuning in. For this workshop for the Infinite Space Bazaar, we're going to be learning about automation, off-chain data, and Gasless with Gelato. So I'm joined by Javier from Gelato, and I'll let him do a quick intro and then take the floor.
Yeah, thanks, Josh. Thank you for having me here. So I'm Javier Donoso. I'm the head of developer relations at Gelato, and I'm helping the customer integrations, our customers to integrate all of our products. I'm very excited to be here and share with you some insights so you can build on this hackathon, and specifically because we have a testnet built on with Sepolia with Celestia that we can test afterwards. So first of all, I would like to give us a short intro that I'm used always to talk with our customers. So imagine when you come to Web3 that you have to create an app. So at the beginning, when you start to participate in hackathons, as you are doing right now, then you think that you're going to have a front end built in React and some smart contracts, and then you are good to go. But as it happens, like it happened to me when I started building on hackathons, then at the end of the day, you need much more things. You need indexing, you need job scheduler, you need off-chain data, you need somehow to relate transactions. If you want to offer gasless transactions to your users, you need notification. Maybe you have somewhere a vault to keep your private keys. And now if we think that since 1 year, more or less, the app chains, the ability to have your own chain is very high, then you will also need to spin your chain. So all of this is actually very complicated. And you as a developer, you should be focusing on building your protocol, building your custom logic, building your awesome application for your users, not building the infrastructure around it. Because imagine, if you have the chance and your protocol scale, you have to scale and maintain different server resources. You will need to manage multiple RPC connections for higher reliability, and you will need to pay different service providers. You will need to have some support other chains if you want cross chain compatibility, and you will need to store somehow the key. So at the end of the day, you are wasting some time in developing things that you should not that someone else can develop for you, and you are the single point of failure because you are concentrated on building infrastructure, and infrastructure should not be the limit in your development. Your custom logic should be the limit. So that's why we actually created Gelato. Sometimes when I remember back in the days when someone asked me why your customers need Gelato, and I always say that actually we try to solve the job that the customer has to do, and in this case, the job of the customer is to have the protocol with the best infrastructure and on the best blockchain possible. So that's why we launched last year the Gelato Rollup as a service, where we have different tech stacks like on Optimism, Polygon, Arbitrum. We have also different data availability like Celestia. Then we have our set of services. We will see later in detail, but we have automation, off-chain data, randomness or account abstractions, and all of the things that are required to build on your blockchain, like block explorers, KYC, wallets, off and on ramp, everything that actually are in the normal classical EVM chains, and you will also need on your rollup. So when we think about the services, and probably Gelato is already well known for all of these services because we started in 2021. So these are what we call our middleware services. Our middleware services are first Web3 functions. Here we have a way to very easily automate, get off-chain data, and then publish transactions depending in your custom logic on chain. And here we have different use cases and customers like the ones that are shown in the slide. We also offer relay. Relay is the ability to send transactions on chain where you can sponsor the gas for your users. It means that for your user is gasless. This is one of the features that are most required to have broader adoption. And we offer also the possibility that to pay this on chain with a transaction while the transaction is executing, or with an off-chain mechanism that we will see also afterwards. We also offer randomness. We work with the different network, and we get the random numbers, we verify the signature, and we push them on chain. We also have a chain compatibility mode for protocols that have already their contract audited and they want to go to another chain, but they don't want to change their contract. So we offer the ability to use this chain compatibility mode so they don't have to change anything on the contract. And we also have account abstraction. We are integrated with the Safecore SDK, and we have our bundler is ERC-4337 compatible, and we have a partnership with ZeroDev. Actually, for the builders in the hackathon, for the audience, this is the most important part of this presentation. Here you can start to perceive the kind of services, the kind of features, the kind of cool project that you can build. We will see later on some ways how we can create a very simple Perp perpetual protocol where we will have setting the order and getting the price from the PIF network oracle, how we can relate transactions and how we can execute transactions depending whether a position has to be liquidated or not. And we will do all of this hands-on. So Web3 functions, and that will be our main part of the presentation. So we write our code on TypeScript. It can also be in Solidity, but the examples that I prepared are on TypeScript. Once we have our code tested and ready to go, we upload our code to IPFS and we receive the CID, the IPFS hash. So our network of executors are running this code upon the triggers that you decide. They can be every second, every 2 seconds, every block. They can run upon certain events that happen on chain, or they can run as a schedule like a cron job. So once this run is happening, then the code says whether it has to publish some transactions on chain or not. We can also query some off-chain data for any HTTP API endpoint that we want, and then we send the payload to be executed on chain. So the Gelato protocol forwards the transaction to the target contract, and the target contract is executed. So as a summary, we have a TypeScript code uploaded to IPFS that is picked up by the Gelato nodes and then is run, and in case a transaction has to be executed, is published on chain. So this is more or less the way how our Web3 functions work. We can see here the different protocols, that more than 500 that they have already integrate some of our services. You see here almost all of the big names in the space: PancakeSwap, Quenta, Synthetics, Yearn, Abracadabra, Aave, MakerDAO, Peace, most of the big names in the space. So specifically for the hackathon, we have $5,500 in gel. This is the bounty, and it has to be the most important premise is that it has to be deployed on our testnet Raspberry. Raspberry, as I said at the beginning, is an OPS stack blockchain with Celestia data availability that we have deployed in production quality mode. And we have also all of the different services on this network. We have functions, we have relay, we have BRF, and a lot of partners, as we can see, we will see afterwards, are already deployed there. So a lot of interesting stuff to build, some bounties to encourage more to build, and let's see how easy can we do this. So in this Perps use case, we will see first the low latency oracle. So the low latency oracle, we have a user that it wants to set an order in the perpetual contract. The Web3 function is listening to this set order event in the perpetual contract, then runs the code that we have prepared in advance. It queries the price from the oracle. In this case, we are using the PIS network. We get the price, and then we settle the order. So with this flow, we can ensure that the price that we are getting for this order is verified on chain, because when we are sending the transaction on chain, this transaction is doing in our smart contract two things. First, verifying, updating the price in the PIS network contract on chain, getting the price, and do the custom logic, in this case, setting the order. So let's have a look in, first of all, our repo. If you want, we can provide this repo, this open source, with the different examples. So here we have our contract. This is, I think it would be better that we go afterwards to the contract. Let me also explain something about the testnet so that you understand where we can start. Wait, it's not working. So here we have the three public testnets that we have already prepared. The one that we were working today is the Celestia Raspberry, which the OP Celestia Raspberry. And when we go there, here we can the URL for this public testnet. I will provide it afterwards, but it's very easy. Ras.Gelato network public testnets. So we are here in the OP Celestia Raspberry. We have it's a testnet. The settlement layer is Sepolia. We have the chain ID. We have the block explorer. That is this one. Is the classical block scout explorer. So we also have the ability to bridge assets. If we click here on, we will have to bridge Sepolia. It takes around three minutes. So in this case, it asks me to switch to Sepolia. So now in 3 minutes, I will have more, sorry, I have to choose. I'm gonna choose 0.5. I'm now bridging the funds. I should have the funds in my network, in the OP Celestia Raspberry, in around 3 minutes. We can see the transaction in the L1, or we can see the balance in the L2 that we will see increase in some minutes. So this is the bridge. We have also a transaction debugger, and we have, which is important for us, is the RPC that we will use for our hard hat project that we're going to see in a moment. Actually, I jumped faster than I should before. So now let's go to our hard hats project, our repo, and let's have a look into our contract. So we have some state with orders that is not really, is important, but it's not worth mentioning right now. We instantiate the so-called ERC2771 context that we will see later on why we need this when we want to relay. And this is what we're going to focus in the first example. We have here the set order, and it emits the set order event. So first of all, we're going to deploy this contract. So in order to deploy and verify the contract, we will go to our hard hat config. Here I have some parameters that I need for the Web3 functions to execute and to query the price. What is important to notice is that the Web3 function has hard hat plugin that we instantiate like this. So we are able to test everything locally. And you cannot imagine helping customers how often when they discover that they have the ability to do end-to-end testing with a fork network, mocking the Web3 function and receiving the results of the calls, actually it is like a 3x speed developing compared to before. So we will see it later. So one thing is we have to create this object so the hard hat plugin can work. We have here the different networks, and in our case is the Raspberry network. This is the RPC that we saw before. This is normal stuff for every project that we know and we have developed, but it is specifically for the custom chains that are not yet like established, is that in order to verify them programmatically, we have to pass this object where we define the API key. Here is not important what we put, but we have to define in the custom chains array one object with this information, the same name as appear here with the chain ID and the block explorer / API, which is the same for the block's Cloud Explorer. One other thing that we have to do to be able to use this configuration is to import the hard hat Etherscan. So we install the Nomic Labs hard hat Etherscan. We create the BRF object. We include the network definition of Raspberry, and we paste the custom chain configuration so we are able to verify. So let's do this. And first, and we start the live demo, yarn deploy network Raspberry. Pachin. So it looks like it's deploying, perfect. We are using this, we are using here this deploy script. So now the contract is deployed. We're gonna see it. In here. Okay, the contract is created. We have here the bytecode, perfect. So let me do a little bit so I don't need to. Okay, perfect. So now what we have to do, we go ahead and verify the contract. And we will do it passing the contract plus the params that we need as constructor arguments, which are first the Gelato messenger. We will come to this later. For now, bear with me, I will only copy it. We have here the Gelato messenger. The second is the peace contract, which also I've defined it here. Oops, sorry. And the third one is the trusted forwarder that we will see what is the use for when we see relay. So perfect. Now, if all run, network Blueberry. Sorry, actually, as I did wrong. It's not Blueberry. It's Raspberry. As we are having different networks, sometimes it's easy to get it wrong. Okay, Raspberry, perfect. So it should. So we're gonna wait for the verification, but we can see later that it works. It's taking some time. Fair enough. Now let's have a look how we create this Web3 function that will do all of the heavy lifting for getting the price from the network and verify and sending the price on chain. So in this folder, we have the folder Web3 functions. Here is where we have our different Web3 functions, and we will start with the Oracle Keeper. This one is the one that we saw in our chart in our presentation before, that is listening to the set order event, and once this set order event is happening, then it will get the price from the PIT network and it will publish on chain. So let's see how it works. We have here this method, this on-run method, and here we have our different contexts that we pass with the Web3 function, and we have all of this information available while the function is running. In this case, we have some arguments that it will be our contract and our price feed, then the storage that we are not using, then we have a multi-chain provider. The multi-chain provider allows you to, you can instantiate the multi-chain provider with the default network where the Web3 function is targeting, but you could also create another provider, like say chain ID 137. So in this case, you would have a provider already available for Polygon, where you can do any RPC calls. You cannot execute, but you can do any RPC calls. So here we get the arguments. And here we start querying the PIT network for the price. So we have here, we establish the connection, we get the price, we create the price object, and then we instantiate our contract that we have just deployed. And we, as this Web3 function is going to be triggered upon an event, we also want to get the parse the event, so we have the relative information there. So we get the current price from this price ID, and then we simply encode the function data for this update price orders. That's when we go to our contract, we have seen that this is the set order that triggers the event, and once the Web3 function is going to run the update price order. And we can see here the only Gelato messenger. That is one of the parameters that we have passed in the constructor. Every time you create a Web3 function, we create a proxy contract that is managed by you, and it's an additional security layer, so you can actually gauge the executions of this method. Then this method can only be executed by the Gelato Web3 function. So going back to our index, here we have we have prepared the data to be executed, and then we return can exec equal true and an array of transactions to be executed. In this case, we only have one. And in the case that we decide nothing should be executed, then we will return can execute equal the false and a message that we will see later on. So now let's have a look on the testing. Okay, the verification is hanging. I don't know why. Let's have a look again. Unknown ID error. Okay, let's have a look whether it's already verified. Yeah, apparently it did verify it properly, but it didn't send back to Hardhat the message that it was already verified. Good. So now if we have a look in our tests, we will first run only the one for the Oracle Keeper. So let's see if we are ready to go. Run test. So perfect, the tests are passing, so I'm able to deploy. So I have already prepared the deploy script. This deploy script is deploying the IPFS code to, the TypeScript code to IPFS, and it will return a CID that is the IPFS hash. So we do this here. Perfect. We have already the CID, which is important for later. So now we have already our code on IPFS, and now we have to create a task that will run when the event is fired. So we go again, and now we go to our Gelato app. Here in our Gelato app, we can see our functions, the relay, the BRF, our services. So we go ahead and create a task. In this case, it's an on-chain event in Raspberry. Perfect. We go to Raspberry. So we go to our contract address. And sorry, that was the test. We have here our contract address. Perfect. So we go here and we input our address. Here we have the ABI decoded, so we can click the event and we say that we want the TypeScript function. And I'm going to go ahead and copy the CID that we just deployed to IPFS. Perfect. And then it's asking me to, sorry, this is not the correct one. Let me see. Actually, it was not this one to deploy. It's not the trigger order. It's the Oracle. So this should be the one. So perfect. So this is the CID for this example. So let's go ahead and input the CID. I see that, let me refresh because maybe with all of this hiccup is not working properly. Create task on chain event. I go here, I copy the contract. I take the set order event, TypeScript function. Then I go ahead and copy the CID. And then I have to pass the contract again as an argument. And I will also pass the price ID that we are querying. But this I can have it from my object here. This is the definition here. So I'm going to go ahead and copy this. Perfect. And we're going to call it set order infinite bazaar. Or maybe we call it the other way around. So we will have 3 altogether, infinite space. Perfect. So let's go ahead and create our task. It should work. So nice. Let me grab again the contract because we will need it just later. So we're gonna go and we have prepared a small React app where we have the contract, not contract. I think it was called like this. No, okay. Should be somewhere there. Is here. Get Perp, that's why. So we have here our contract. We will then start in between. Let's have a look if our transaction did. Perfect. The function is active. We don't have any executions. We don't have any logs. Here we can see the code, and in this case, we don't need storage or secrets, which are secrets you can save some specific API keys that no one should see. You have the ability to do this. So now is the moment of the truth. Let's go ahead and, okay, we have here, let's see, the inspection is going to be a lot of errors because it's a very, what is happening? It's happening something, because normally it should, what is happening here? It's not working the PIP network API. Actually, it should here now. Okay. It starts to show some prices. It's actually querying every 2 seconds, 3 seconds the price, and then we say that we want to create an order. So let's create an order. We confirm the order. We wait a moment that the order has been finished. Actually, if we go to the contract, probably we will see that the contract, you can see how fast is this network, because already transaction has been executed. Actually, here we are waiting for the feedback from the contract from the event. Sometimes, depending on the RPC, it needs some time. Okay, if we now go to the Gelato app, we see here there is an error. Okay, that should not be. There is an error. I passed correctly the address. I passed correctly the QM. Normally, we should see here the executions. I don't know why. I don't know. Let's move forward. Normally, here we should see that what we just did execute properly. I had prepared one other task this morning that is the same, and I want to show you so you can see what are the expected results. That was the so-called Celestia order, and here you can see that it's triggering every time there is an order to settle, and when there is an order to settle, then executes the transaction. And here we can see the different transactions I tested. So this is normally what we should have received in this live demo. Sorry for that. If we have some time afterwards, we will do it again. So the second point, which is interesting, I'm going to stop our React app. And the second point that is interesting is now what we have seen is that we have sent transactions to a contract. But what if we would like to sponsor the gas for our users? What if we would like to offer gasless experience for our users? Then we will need to use relay. So I've prepared some schematic presentation about the relay concepts. This is what we just did. Our user is sending a transaction to a smart contract, and the contract can read the message.sender, which is the user, and the message.value. So what happens when we want to relay a transaction? When we are using a relayer, it means that someone is sending the transactions on chain. It means our Gelato relay. So the user send the HTTP request to the Gelato relay contract. Then the Gelato relay contract, which is on-chain for sure, forwards the transaction to the smart contract. And here, as you see, there are different things that have to be kept in mind. One, the message.sender is not more the user. The message.sender is the Gelato relay contract. And this brings sometimes some confusion. So the second one is that there is no possibility to send value. There's no way to attach value, because the value should be attached from this user that is sending the transaction. So, and here we are sending an HTTP request. We are not sending any value in any transaction that we can transfer value. So the message.value is not possible to be transferred with a relay transaction. So what we see in some of our customers is using the permit function on ERC20 tokens to be able to send transactions to transfer tokens that within the transaction has encoded the signature for the permit method. So then how these transactions are paid? Because at the end of the day, you are sending here, the user is sending a normal HTTP request to our Gelato relay backend, and we, Gelato, are pushing the transaction on chain. So it means that in this case, we are paying for the gas cost, for the gas fees. So what options does the user have to pay back the gas fees? So we have two options. One is the off-chain one balance. We have on Polygon where you can deposit USDC, and then this USDC on Polygon will pay for all of the chains where we are. For Raspberry also. In the case of testnet, we should deposit some Sepolia is on Sepolia. Moving forward, we will also accept USDC payment in other networks, but for the time being, we have one gas tank with USDC on Polygon, and all of the transactions for mainnets that our users are doing through all of the networks are paid with this one balance. And the second way of paying the transactions is using the so-called sync fee methods. The sync fee methods are some helper methods that you include in your contract, and while the transaction is executed, you query the fee details and you transfer while executing the fee to Gelato. It's also possible, we have some customers using it. It's a little bit less efficient because as here all of the accounting in one balance is on chain, and only we push after several hours a Merkle route on chain is much more efficient because all of the heavy lifting of the accounting is happening off chain. So the one balance is also important because it's also how we pay the Web3 functions executions as we saw before. So another thing which is very important is we saw that the message.sender is not the user sending the request, is the Gelato relay contract. But what if I need the information about the user? How I can be sure that that in the transaction, if you want to append the user, that actually this user is sending this transaction? Then in order to do this, we have the ERC 2771 methodology. And the way how it works is that the user send the HTTP request off chain. Then before, when we send the transaction, our MetaMask pop up so we can sync the transaction and pay and confirm the transaction. Here it will pop up so we can sign the transaction, but we don't have to pay anything. So the signature is appended with the payload to the request, is sent to the Gelato relay, and we decode the signature to check whether the user sending this transaction is the one that signed the payload. We will do this with the EIP 712. So once we do that, we append the address of the user to the call data. So in the smart contract, implementing the ERC 2771 context, we can slice the 20 last bytes of the call data, and this is actually our address, the user sending the transaction. Here is very important that we only accept this when the contract sending this transaction is our trusted forwarder. That's why when we saw before in our contract that we pass the trusted forwarder is to ensure that no one can send any payload with any appended address at the end of the call data. So ensuring that only we accept to the code the address when the trusted forwarder is the Gelato relay contract, then we can do the step 3 and decode the original user. It's always when we talk with our customers, we reinforce this message that is very sensitive, because once you have decoded your user in your contract, you can act as the one sending the transaction is your user. So you have to be sure that the one that is telling you that this user is legit is our Gelato relay contract. So if we go ahead to our UI, and here we will see the set order sign. Now let's go ahead and look for the method. Set orders, set conditional order, set execute margin order, set order gasless. Here we're going to see how the implementation looks like. Normally, in what we saw before, we will only have the Perp contract, which is our contract that we have deployed, and simply set order and passing the value. And it will execute here. We prepare the data by populating the transaction. It means that here we have the payload that we're going to send. We pass the chain ID, in this case is Raspberry. Here we have the target contract, is the target receiving our payload. Here we have the data and the signer address, the one that is going to sign the transaction. Then we do a very simple sponsored, this is our SDK. And here we have our sponsored call, which is the method that we are going to call, passing the request, the provider, Gelato relay API key that we use so that it will be decreased from your one balance. And we will receive the URL where we can see the status of the call. So let's go ahead and do it again. Perfect, we are here. This is working. So I'm going to click Gasless. Now, when I'm doing setting an order, we should receive the MetaMask that is going to pop up and asking us to sign, not to confirm the transaction. Now we are relaying the transaction. And now very shortly we will see the hash of the transaction that we can see now that is already succeeded. And actually we have mimicked the transaction that we have seen at the beginning, but here with relay. Let's have a look if our function in this case has picked up properly the, let's see if still we have the error. Yeah, normally if we don't change anything, it should be the same error. So I think I could show better more than debugging, probably something that is I forgot to update or to change. I think it's better that we see the different use cases that we also have in our report. So let's go ahead and see the next use case. The next use case is actually a little bit different. We have orders, but we don't have orders that have to automatically be settled. In this case, we have a conditional order. Imagine you have your price at $3,000 if, and you say, I want to execute this this conditional order when the price is 5,000, or when the price goes down to 1,500. So we create, we send the transaction to our contract. We will see the method. Here, this Web3 function is not reacting, is not only triggering when the event is happening, is constantly, like in a 5 seconds interval or 2 seconds interval, querying the events from this perpetual contract. And in the case that it found some events that matches this the conditional order method, it will then store in the Web3 function storage that before we saw that we didn't use it. Now we're going to use the storage, and then every 5 seconds, it's going to check all of these orders. We will create an array, and every time it checks whether we receive a price from the PIT network and whether the price it makes that the conditional order executes or not. So let's go ahead and see the code. This is the second use case, the conditional order. Here we call it trigger order. So we have here our, we don't have log as we have before, because now we are not only listening to a log. Actually, we are storing in our storage the last process log that we analyze, and we also store and get the array of orders that we want to execute, that we want to check by every run. So we instantiate the contract, we do the connection as we did before with PIT, we get the price, we prepare the price object, and here we are going to read the events directly from the contract, and we are going to read between different block numbers, and it's a kind of loop. So, and here, what is important to retain is that we push the orders to an array, and then we check whether the price is above or below, depending on the logic, and then we prepare the orders ready to be published. And we store the new last processed block and the new orders to fulfill without the ones that are going to be executed. And in this case, if we have some orders to execute, we return the payload as before. And if not, then we console log the remaining orders, and we say not orders to settle. So if we have a look into the contract, like before, we're going to see set conditional order. This is the events that we're going to use to query the logs from the contract. We are not listening to this event. We are triggering the function every 5 seconds. And this is the function that it will get executed by the Web3 function, as we see the only Gelato message.sender. So let's go ahead and deploy this one. Maybe in these last minutes that we have, it's going to work. I don't know if I'm doing something. Deploy order. We could run the test. I ran it before they were working. And maybe from the test, it's very interesting to notice what I said before about the end-to-end testing. Okay, here. Let me see. Probably in the next, as we won't have time to go over the next example, but it's maybe worth have a look here at this. Exactly. Here we see in our test that we get the Web3 function code, and we will run this Web3 function locally. This Web3 function, remember what we saw in the code, return a call data and a target address. So we can execute this locally. So this is about testing. We don't have more time to look at this in detail, but let's have a look. And we're going to deploy to the functions. We're going to create one more function. So in this case, we're going to execute every 5 seconds. We have a TypeScript function. In this case, it's asking me about the contract. I know. Sorry, actually, we have to pass always a small fee to PIT when we execute, when we update the price. And this contract has 0 balance. So let me go ahead and, yeah, see. So we are in here. This is the contract of the address, and I'm going to. It's only one way that actually the contract transfer. So the last 5 minutes at least, we're going to see that it works. Okay, we have already 0.1. So now let's go again and set one more order. We will do it with relay again. Why not? You're gonna see the transaction, it executes, perfect. And now the only thing that we are waiting is that our all settle order task, which is the infinite Space Bazaar, exec pending, perfect, bravo, is working. So now we will have the execution. In the next seconds, it will execute it. Perfect, it has executed, and now if we refresh, we can see that actually we have the published time from this order. In this case, we can see that it took 8 seconds to do all of the journey from relaying the Web3 function, waiting for the event, running the code, getting the price from PIF, and then publish the transaction on chain. And we are on a testnet. So our backend is not so performant as in on production. So I think we could have a look. We could deploy the next Web3 function, but I think that the process is actually the same. So I think that it's better that we allow the users to have some questions, the viewers, if they have a specific interest in some of the parts that we have discussed. I'm happy that at least at the end we could see that the Web3 function was working. So without anything more to say, then I think here is where my presentation finished. I'm happy to take any questions that are asked.
Awesome. Thank you, Javier. I think I don't think we have any questions in the chat. Yeah, at least not on YouTube. But I am curious. You showed us using Hardhat. I was wondering if developers can use Foundry as well.
Yeah, you can use Foundry for like doing all of the tests, but for the plugin to do the testing, like the end-to-end, you cannot use it. You will need to call the Web3 function normally, get the call data, and pass it to the contract. But easily, you will have to do some more steps. It's not so simple as this, that is only one line that it says get Web3 function, run Web3 function, get call data.
Thank you. Yeah, it's always fun to do live demos, but it's always funny to see what we run into. I'm glad you figured it out at the end there.
Yeah, and the thing is that I tried twice today, and it worked. And then I didn't change anything. Then you were thinking that why it doesn't work now? You don't have any, but then it was still it's true that the step that we have to fund the contract.
Yeah, I guess I'm curious if you have any suggestions for the hackers on what they could build with Gelato, other than what you showed us today.
Yeah, I think that any project that tries to provide some user experience that is beyond what we see, we have shown, for instance, the Gasless experience, but still you have to sign every time. Probably you could have like a proxy contract somewhere, create some session keys locally, and then with this session key validated in this proxy contract, probably if you know how to do it, you could have a signless experience where you only sign once, and then you can send all of the trades without any signature more. This is something that maybe is interesting for when you want to showcase your project. So anything that is related to off-chain data, lottery with BRF, any games. We have seen an explosion on blast of BRF customers, customers playing like mad, and so randomness, a game that you can do signless, maybe a game where you can also um, buy some weapons or lend some weapons, because you can with automate with Web3 functions, you can ensure that the user is going to give you back your weapon. So all of these kind of things that you can all of these features that can make that your application stand out, like a normal Web2 game, for instance, or lottery, or anything. Actually, we have seen so many things. Today, I was in a meeting with Sedran, that actually they are using us for breeding the horses and for lending the horses. Sedran is a horse race, a digital horse race, and they are using us for this. We also have very, very interesting projects. Like we have one. I don't know if you are aware about Superfluid. Superfluid is like a streaming money protocol, and then we have one customer that one protocol that it has a vault, and it pays the fees to the protocol in a stream, depending on the total volume that is locked in the vault. So every day with Gelato, it does all of the math for calculating how much should be the new stream, and then update the stream, and then without nothing to do. Awesome. So now we have a lot of intensive protocols that they are testing, like Ostium and Arbitrum, that is going to be a Perp DEX, that is like they're going to do everything with us. So it's actually very interesting. We have these two categories: the middleware, that is where I'm more like helping developers, customers, and then we have the RAS, our chains, like the Raspberry, where we implemented Celestia, and we are very happy with. But this is more or less our different types of services.
Awesome. Yeah, thank you again for the summary there. If I were a developer who had questions about Gelato, where is the best place to reach out during the Infinite Space Bazaar?
Yeah, I only know one person which is faster than me, and is Anirudh, and one of my team members, and he's probably already in Discord. He's in India, so maybe for late times in America, he's not going to be there, but then I'm going to be there if he's not there. So Discord, and tagging me, Donoso if, or tagging Anirudh Makana, who is actually already there.
Great. I'm going to do a last call for questions in the chat. I don't see any. But also, yeah, if you're tuning in now, we'll have another workshop in an hour. And on the note of gaming, we'll be going over the World Engine with Scott from Argus Labs.
Nice, really cool.
Yeah, it's a good segue into you're talking about gaming.
Yeah, indeed.
Hi, Anirudh.
We have still your effects for saying goodbye, like at the beginning.
Oh yeah, yeah. Thank you again, Javier. I don't know if it'll work. I put a green screen.
Now, no, but before it was nice.
It doesn't know what's going on. There we go. It's gonna blur it out though. Thank you again for teaching us about Gelato, and we look forward to working with Gelato for the rest of the ISB and beyond.
Sure. Thank you very much for having me here. I appreciate it.
Yeah,
I enjoy it.
Have a good one.